Good morning, folks, and thanks so much for joining us this morning. I know it's the last day of reInvent, and it's just awesome to see a really full house here to learn more about pipes. My name is Nick Smith, and I'm the Principal Product Manager for Amazon EventBridge, and I'm joined by Jamie Dool, who's the General Manager for Amazon EventBridge. So today we're really excited to be talking to you about Pipes, which launched yesterday in Werner's keynote. Pipes provides a simple, consistent, and cost-effective way to create point-to-point integrations between event producers and event consumers. We're going to talk about why you need to create integrations in the first place and why that can be sometimes quite difficult and complex. We're then going to jump into how Pipes helps make that easy. We'll explore a couple of use cases for Pipes and then actually hop into a demo to see how it works. From there, we'll do a quick wrap-up about some of the things that we're going to be adding to Pipes in the future. OK, so let's start off by talking about the problem that we're trying to solve, which in essence is about integrations. AWS has more services and more features within those services than any other cloud provider by a long way. And these services are designed as building blocks that you can assemble together to create a complete solution. And this gives you an application that is highly scalable, resilient, and crucially is really easy to extend and add more features by adding more of these building blocks. This saves you from having to invest all of your developer resources into managing infrastructure and data centers, and allows your developers to instead focus on creating business value and creating differentiated experiences for your customers. And so the services that I've talked about here as building blocks, these are incredibly powerful and allow you to pick the right tool for the right job. So if you need a database, you can use DynamoDB that provides incredible performance and massive scale at low latency. If you're streaming huge amounts of data, Kinesis Data Streams has you covered. And if you need to handle spiky workloads in a queuing kind of form, then you can use SQS that gives you pretty much unlimited throughput. And so the idea is that you can assemble these building blocks together to create a solution that scales, that's resilient, and that's reliable. And you can do this with that flexibility to extend. OK, so we have these building blocks, and we assemble them together. And we get this, your architecture diagram. You've probably seen hundreds of these before, and they're really a visual representation of your application. They explain what services you're using and how you're connecting them together. But one of the difficulties with this building block type approach to assembling your application is that you have to spend quite a lot of time connecting those building blocks together. Think about all of those architecture diagrams. They all have these lines that connect the services together. But a lot of those times, the lines between those blocks can be quite complex. So for example, here we've got an architecture diagram where we've got a DynamoDB stream that we want to connect to SQS. Perhaps we have something that wants to process from that queue changes to our database. And so in this case, it looks fairly simple. We have a DynamoDB stream, and then we have SQS on the right. But what you don't realize here is that you actually have to write integration code to pull that DynamoDB stream and place those events onto the SQS queue. So we call this integration code, or glue code. And it can actually be quite tricky and time-consuming to write this integration code. On the face of it, it might not seem like it. But when you actually think through it, there's quite a lot that you have to consider. First off, there's a lot of nuances between the different services and how they communicate. Take Kinesis, for example. You need to use the Kinesis client library to pull a Kinesis stream. You need to know about how shards work and that you have to have a single consumer per shard. You also need to keep track of your sequence IDs so that you know whereabouts you are on that stream. On the other hand, if you're using SQS, you need to know that you can have many consumers that can all pull the same stream or the same queue, unlike Kinesis, where you have a single consumer per stream. With SQS, you use the AWS SDK, not the Kinesis client library. And with SQS, you need to know that you have to delete a message after you've consumed it. So even between these two services, a lot of differences in how they work that developers have to figure out. So once you've figured out those differences, you have to think about how you handle errors in your integration. If you're doing batching, you'll have to handle partial failures. And if you're doing ordering, you'll need to keep track of what the last message was that you processed, in case you have some impact to your service and you have to come back online and continue where you left off. Once you've done that and written that code, you then have to think about your target service, the one that you're wanting to actually send your events or messages to. And here you have to consider authentication, permissions for that service, what the API looks like. And if you're using a non-AWS service as a target, say you have a third-party SaaS API that you're trying to call, you have to figure out how to authenticate against that. And you also have to consider things like flow control or rate control. You don't want to overwhelm some third-party API that might not be able to take the load that you're wanting to send at it. So once you've written all of that code, you then need to consider performance testing. You want to make sure you allocate the right amount of CPU and memory resources. And you also need to actually benchmark that integration to ensure you have the right amount of throughput for your use case. Then you'll have to deploy that code. And lastly, manage the ops and monitoring for that. You want to make sure that if you have increased latency on that integration or failures, that you're actually alarmed and you're notified about that. So even a simple integration like a DynamoDB stream to SQS can end up having a lot that your developers and you have to consider. So all of these considerations reduce your developer velocity. They increase the risk of having bugs in your code. And they make your app more complex and inefficient. And this increases your operational load. And so the end result is a higher total cost of ownership as you spend more of your developer resources writing integrations instead of focusing on that business logic that differentiates your business.
Great, thanks, Nick. So there we go. So now we understand some of the challenges that AWS developers are facing. And to address those challenges, we've announced EventBridge Pipes, a new feature of EventBridge that makes it easy for developers to build event-driven applications that integrate event-driven services in a simple, consistent, cost-effective manner without having to write additional code. Today, pipes support consuming from 6 event sources, enriching through 4 services, and delivery to 14 services, including HTTP endpoints via API destinations. And we're very excited to be here today to tell you how pipes can help you in your applications. But before I jump into all the great things that pipes can do, I want to just do a little informal poll here. We have been monitoring our dashboard since we announced the feature yesterday, and have seen upwards of several hundred customers already give it a try. So I'm curious, who in the room here still on Friday has tried it out? Can you just raise your hand? Okay, few, not too many. So, okay, so lots of new learning today, that's great. Okay, so what can a pipe do? Firstly, a pipe supports filtering. As customers evolve their applications with discrete microservices, they often want to consume only the events that are appropriate to that service. So being able to filter a source ensures that the service gets only what it needs. Pipes support batching on both consumption and delivery, ensuring integrations between services are highly efficient. For ordered sources, pipes retain that ordering and deliver each event synchronously to ensure ordering is maintained. Pipes support high concurrency, ensuring the integrations between services scale as the volume of events grow. And finally, pipes support an enrichment step, allowing for unique business logic to be applied to the consumption of a source and change that on its delivery to the target. So why would you want to use a pipe? Pipes enable developers to move faster by eliminating the undifferentiated integration code that you're writing and maintaining today. Pipes help you save money from needlessly processing events your applications don't need, and you only pay for events you want to process. Pipes provide fully managed polling, allowing your applications to react as and when new events arrive. Finally, Pipes removes the burden of managing the code, infrastructure, and scaling of your point-to-point service integrations. So I want to step back for just a moment and share a little bit of what inspired us to build Pipes in the first place. In 1973, nearly 50 years ago, Unix pipes were introduced as a way to compose novel solutions using purpose-built executables connected together over a common ASCII text protocol. Later, this concept evolved into software architectures and then into enterprise integration patterns. And all of these three things are still, all these three innovations continue to be practiced by developers today. As Nick talked about earlier, AWS provides tremendous breadth of purpose-built services that enable developers to innovate at cloud scale faster than ever before. And so we conceived of EventBridge Pipes as a way to extend these integration patterns to the AWS cloud. So before we get into the details of pipes, let's first address, we are launching pipes as a capability of EventBridge. So we'll take a moment to talk about how pipes are different from the core event bus capability of EventBridge. Looking back, we launched EventBridge in 2019. And if you've been with AWS for a while now, you may know that evolved from CloudWatch events. Customers love CloudWatch events because it allowed them to respond to changes in their AWS environments in near real time. Many of these early use cases were mostly appropriate to DevOps or SRE type use cases, but it demonstrated the power of event-driven development in the cloud. So we saw an opportunity to bring this powerful paradigm with the ability to react in near real-time approach to all of the changes occurring across your business. We launched EventBridge with a serverless spin as a platform to make it easy for customers to bring all of their business events to an infinitely scalable, always available, pay only for what you use enterprise solution that allows many publishers and many consumers to easily integrate with each other, and in so remove much of the heavy lifting. Pardon me, whoops, sorry. Oh, what just happened? Don't spend a lot of time in PowerPoint. There we go. Well, this is not working. OK, here we go. Pipes extend the same benefits to event-driven point-to-point integration. Oh, sorry, let me step back. We launched, losing my space. Pipes extends the same benefits to event-driven point-to-point integrations by removing the undifferentiated heavy lifting required in wiring together the many building blocks of AWS. Both event buses and pipes help developers move faster, focus on their core business logic, and reduce the code your teams have to manage and scale. Event buses address many producers and many consumers, while pipes focus on one-to-one integrations between services. So those of you that are familiar with Lambda may be starting to see some of the similarities between the sources that pipes support. Those not familiar with Lambda, you may be seeing some commonality in the sources that pipes support in that they're all services that require some form of polling. Every developer using these services needs to understand how the unique or nuanced approaches to polling work. They need to understand how to scale as the workload grows, how to handle unhappy path error conditions, and again, have to develop and maintain this code, which takes time away from building the unique capabilities of your business. Pipes share the same at-scale managed polling infrastructure that Lambda event source mappings do, and we extend that capability to poll and deliver to over 14 AWS services. This production-proven capability is used by over 150,000 users operating over 1 million ESMs that process over 1 million transactions per second. So this lineage makes pipes ready to tackle the scale of all your supported sources today. So let's talk about a few use cases. With 6 supported sources, 4 supported enrichment services, and 14 supported delivery targets, pipes allows for over 100 integrations without requiring you to write any integration code. So let's jump into a few of those integrations and get a sense of what's possible. OK, so the most basic use case. On the left-hand side, we have an SQS queue, a hugely popular AWS service, often referred to as the infinite buffer in the sky. On the right-hand side, we have a step function, another popular service that makes it easy to orchestrate complex workflows. There are many ways to achieve this, but one of the easiest ways is to use event source mappings to connect a queue to a Lambda. In this case, you have to write the code to invoke the state machine, consider the throughput and concurrency requirements, test the code, deploy the code, and manage the code through the lifecycle of the application. Now with pipes, navigate to the EventBridge console, create a new pipe, select the source queue and the state machine as your destination, finish with create pipe, and that's it. You're done. Your queue is now wired to your state machine, no code written, and now you're ready to move on to your next business challenge. OK, this next use case will leverage the filtering capability of pipes. In this example, we have a Kinesis data stream, and this stream may contain, say, all of the clickstream data from your web application. And your teams have a desire to split this stream into multiple domain-specific streams. The need to split a stream maybe comes from where one team is just interested in processing the user behavior that is associated with the portion of the web app that they own. Another reason might be a specific use case or analytic case that only applies to a subset of the stream. And yet one more reason may be to simply expand the read capacity of a given stream to more consumers. With pipes, you can introduce two or more pipes from the same stream, apply a filter pattern in the same semantics as an EventBridge rule, and target a new stream that will contain only the subset of events by which the stream consumer is interested in. Like we saw in the first example, to achieve this, you would follow the same set of steps. First, creating a new pipe, then choosing the aggregated Kinesis stream as the source. But in this case, our second step is to define a filter pattern to match only the events that we're interested in. Once again, without writing any code, we have easily split the stream into two, and now we're ready to move on to solving the business problems offered by those individual streams. OK, this next example builds on the previous, where we had pipes with filters, and now we introduce the enrichment capability of the pipe. Here we have a managed Kafka cluster living in a VPC, and we want to leverage more of the purpose-built capabilities of AWS while integrating this event data with another service that we own, which sits behind an API. To achieve this, we create a pipe, define a filter, and choose a SageMaker pipeline to train our SageMaker model. We follow the same steps as before with create pipe, and again, without writing any code, we have integrated our self-managed Kafka source with a native AWS machine learning capability. Next, we want to integrate one or more topics from our Kafka instance with an existing system that is fronted by an API. Before we do that, we need to apply some business logic to the event. To achieve this, we follow the same steps. We select our source, we define a filter to select the subset of events we're interested in processing, and then we leverage the optional enrichment step to select a Lambda function that will apply our business logic on incoming events before sending it to the API destination configured for our service. Now you might be saying, but Jamie, I thought you wrote some code this time. I thought this was integration without code. And you're right, but there's a difference here. In our enrichment Lambda function, you were only writing business logic. There's no glue code required to call the API. You simply return from this Lambda with the data in the shape your API requires, and the pipe takes care of making the API call and passing your freshly enriched data. OK, and finally, on this last use case, which I'll move through quickly, I want to demonstrate how pipes can fit into your event-driven journey. In this case, our source is a DynamoDB table. And over time, data in this table is becoming more and more interesting to more and more consumers within your business who want to react in real time to record-level changes to this table. Now, you can have many pipes and event source mappings connected to this table. However, each contributes to the read capacity and may result in throttling, which is why we recommend only 2 consumers at one time. To solve this, we can use a pipe as a single consumer of a stream to publish the events to EventStream, to EventBridge, where many consumers can subscribe to the events without impacting the capacity of that stream. Starting off with this pattern provides some future-proofing of this event source, as more of your teams and systems find unique ways to derive value from these events. Now I'll pass it back to Nick so he can show us a demo.
Thanks, Jamie. OK, so we're going to hop into a demo. Jamie's given us some great use cases. I'm going to go through 2 demos that we'll create here, 2 pipes that we're going to do. The first is a super simple one. Jamie showed us that use case of going from SQS to step functions. Today, that's something that you would actually have to write code for. Typically, a Lambda function to go and pull that SQS queue and then invoke your step function. So we're going to see how we can do that really simply with a pipe. The next one is a more complex use case that we'll build, more advanced. In this one, we've got a Kinesis stream that has a whole lot of customer support messages or events that come in. But this stream has customer support tickets that are, or messages that are what we call thin events. So the event in that Kinesis stream has only the type of event it is, support ticket created, or an agent logged off or logged on, and then an ID to reference for that particular event. And so what we actually need to do here is we want to go out and look up that particular ticket ID or resource that we've mentioned in our thin event and populate it with all of the data related to that event. And so to do that, in this case, we're going to use Zendesk, a kind of popular third-party SaaS application for managing our tickets. So we want to make an API call out to Zendesk to go and get the data about a ticket. And we want to then put that onto an SQS queue. So we'll see the filtering and enrichment capabilities of the pipe in the second demo. OK, let's take a look. There we go. We've got my screen, and I'm going to refresh just to make sure that I am logged in. OK, so here I am on the pipes console. You can see this is now a new navigation item in the EventBridge console on the left-hand side. And I've got no pipes created so far. I've gone ahead and created an SQS queue. You can see I've got my orders queue, and then later on we'll use this support tickets queue. So I'm going to go into my orders queue, and you can see that I don't have any messages in there right now. And then I have a step function that I've created. So this is the order processor step function. And all this does, it's super simple. It takes in an event and then passes it out as an output. So really, we're just kind of using it to just log what's coming in and what's going out. OK, so I've got my source, the SQS queue, and I've got my target, the step function. So I'll head back to the pipes console, click the create pipe button. I'm going to give this a name. We'll call it order processing pipe. And then I can select my source for this particular pipe. So you can see we've got a range of different sources that Jamie mentioned: Kinesis, SQS, DynamoDB, Amazon MQ, self-managed Kafka, and Amazon MSK. So in this case, I'm going to select SQS, and then I'll choose my orders queue. And in this example, I'm kind of pretending that I have some e-commerce system that's putting events onto that SQS queue, and I'll use those in step functions. You can also go and set some properties, for example, the batch size, the batch window. I'm just going to use the defaults that we have here. So you can see the pipe has that filtering and enrichment step. I'm not going to use that for this example. We'll get to those in the next example. So I'll remove those. The next thing I've got here is the target. So I want to use step functions as my target. And I can see my state machine, that order processor that I showed you just now. So that's it. That's the pipe. It's got a source, and it's got a target. And remember, if I wanted to do this today, I would have to write that code to integrate the two. So what I'll do is hit the create pipe button. That happens asynchronously, so I'm going to let that complete. And I'll hop over to my SQS queue, and we'll start building a message that we're going to send. We'll give this an order ID. We'll give it an ID of 10. And let's just say we have an order value, and we'll make that 100. This is obviously not going to get used. It'll just come through in our step function. So I'll hop back to the pipe page. I can see that that pipe is now running. And so I'm going to go ahead and send that message from SQS. So I hit send. And now my expectation is when I hop over to the step function, I can go over to the executions, and we can see that there's a successful execution. And if I look at the input and output here, you can see that that event that we sent with an order ID of 10 and an order value of 100 has come through. So I think that was about less than a minute, and we managed to get an integration from SQS straight to step functions. OK, so that was our simpler example. Let's now hop over to the more advanced one. Here I've got a Kinesis stream. It's our support stream, we're calling it. And I've got a bunch of messages that I'm going to send to that stream just now. I told you I had those thin events, so you can see there's this support ticket created event. It's got a ticket ID of 1. I've got a support ticket resolved, a support ticket updated, and an agent logged out. So in my case, I don't actually care about these support ticket resolved and updated and signed out use cases. I just care about when support tickets are created. So I want to filter out all those other events. But then what I want to do is I want to populate this event with more data. I want to know who created the ticket, what's in there. So if I hop back here, you can see I've got my Zendesk agent platform up here. And you can see that there's this support ticket that I have. I'll click on it. It's got a whole bunch of details, who requested this support ticket, and the contents of the ticket. So what I want is for my event that I actually place on that SQS queue to have all of this data added to it. So what I'm going to do is I'm going to go ahead and first start by creating an API destination. API destinations is a feature of EventBridge that allows you to make API calls out to third-party APIs. So I'm going to create this API destination using the Zendesk API that will go and fetch those tickets from the full data of those tickets from Zendesk and then return that to the pipe for our enrichment step. So I'll go ahead and create my API destination. We'll call this the Zendesk ticket or get ticket. And then I've got to pop in the actual endpoint. So I'll hop back. I've got a little cheat sheet here. And we'll put in this URL. So what you can see, if I zoom in a touch, is that this URL actually has a star in the URL. And what that does is allows us to actually dynamically map parts of the URL to a field in our event. So you saw that those events that I had a ticket ID. I actually want to map that ID to this particular part of the URL, so that depending on my ticket ID, it'll go out and get the right ticket information. I then am going to set this as a GET request to the API, and I'm going to leave the rate limiting. And I'll choose the authentication that I've set up previously for Zendesk. So I go ahead and create that API destination. Now that I have that, I've got all the different pieces that I need for my pipe. I have the support stream, the Kinesis stream that we have. I've got the API destination that we'll use for enrichment. And then I've got this SQS queue that I've created, our support tickets queue that we're going to actually send these events to. So I'll hop into the pipes console, and I'm going to create a new pipe. We'll name this pipe the support tickets, pipe. And we're going to go ahead and select that Kinesis stream as the source. So that's our support stream. And then I can choose my starting position. So I can tell the pipe to go all the way back in time, the trim horizon, to the very start of the events that that Kinesis stream has. I can start at a particular timestamp, or I can start just at the latest events that come through. I'm going to pick the latest over here. I can also configure things like the batch size, the batch window, how much concurrency we want on the stream, and the partial batch failures. Another interesting thing here with Kinesis is that we can actually set a dead letter queue for this particular pipe. So with Kinesis, we process events in order, and there might be a situation where one of the events in that Kinesis stream cannot be successfully processed. So what normally would happen is that's called a poison pull, and we're not actually able to move on from that event. But with pipes, we can set an SQS queue as a dead letter queue, and we'll simply take that event that cannot be invoked to the target and place it in the SQS queue, and then continue processing the rest of that Kinesis stream. But in this case, I'm going to just leave the dead letter queue. I hopefully won't need that. Famous last words. So we've got our Kinesis stream set up. The next step that I'm going to do is actually create a filter on this particular pipe. So I mentioned that I have all these events that are coming into the stream, but I'm actually only interested in these support ticket created events. So again, I'm going to hop over to my cheat sheet and just copy this, and I'll talk through this. Essentially, what we're doing here is we're telling the pipe we only want to match against events that have a type of support ticket created. And like EventBridge rules, we are able to use a whole bunch of different content filters here. So you can do things like prefix matching, anything but matching, numeric range. There's a whole lot of powerful ways that you can filter events. So I've got my event filter set up to match those support ticket created events. The next step that I'm going to go to is the enrichment step. So we want to go out to Zendesk and query for more information about our ticket. So I select API destinations, and while I'm here, you can see you can use Lambda, step functions, and API gateway as enrichments as well. But in this case, we'll use API destinations. And then I'm going to use that Zendesk get ticket API destination. Now you can see here, I mentioned earlier that we have that asterisk in the URL. This is where I get to actually map that asterisk to a particular field in our event. So back to my cheat sheet. And I've got that JSON path for this particular field, which is the ticket ID that we have in that source event. So I've got my enrichment set up, and the last bit that we'll do here is then select that SQS queue that we created. And so that is our support tickets queue. So just going through that once more, we have a source that's our Kinesis stream. We've set up filtering to only get those support ticket created events. We've got our API destination configured to go and fetch the full payload of that particular ticket from Zendesk, and then we're going to go and place that onto SQS. So I'll go ahead and create the pipe. Now, when we set up Kinesis as a source, it takes a couple of sometimes seconds, hopefully not minutes, to configure that. But one of the things I'll show you while that's getting created is the IAM roles that get created for you. And I think this is a really powerful part of pipes. If you think about having to write all of this on your own and actually create the code for this, you've got to go and figure out what permissions you need for each of the steps of that integration. You've got to figure out, what do you have to do to pull that Kinesis stream. You've got to think about calling API destinations and permissions related to that, and then for your target as well. But with the pipes console, what we do is actually figure out the permissions that you need for each of the resources in that particular pipe, and we go ahead and create that IAM role for you. So you can see here I've got an API destination set up. It's configured the permissions for my Zendesk get ticket API destination. We've got that Kinesis stream configured, so it figures out all of the different actions it needs to perform on the Kinesis stream. And then we've got our SQSQ configured here as well. So the pipe takes care of creating and figuring out all of those permissions for you. OK, let's head back to the pipe. Hopefully this is created. Create failed. Let me see if I can try that once more. I think this might have been just a little something there we go, it's running. So we have some delays in creating an IAM role, and I think I ran into one of those issues, known issue. It should be fixed soon. So hopefully now my pipe is running, and what I'm going to do is go ahead and actually send those events that I showed you earlier to our Kinesis stream. Kinesis requires these events to be base 64, so I've got this records base 64, which essentially is just the same as this particular set of events. It's just base 64ing them. So I'll hop over to my CLI, and I'm going to call the put record CLI command. And you can see that's gone ahead and sent those events to Kinesis. If I hop over then to Kinesis, where are we? Look at our data viewer. I can go and say, let's look at a particular sequence number, and hopefully we will see our records in there. Whoops, what's happening there? It was on shard 3? Oh, thanks. OK, let's try and check that we got those. There we go. So we can see that Kinesis stream's got various support tickets or support events that we had created there. So the support ticket created, the agent logged out. And so what we're expecting to happen here is for the pipe to actually filter those events and for only that support ticket created event to land up on our SQSQ. And of course, we expect then to have gone out to Zendesk and got the full details about that ticket. So if I hop back over to SQS, and hopefully I don't have to send those events again, we'll see if they're there. Might still be setting up the permissions on this, so I hope that it comes through. Yeah, there we go. So we can see here, I'll copy this from the SQSQ and just put it into Sublime so we can format it a bit nicer. What's happened here is that support ticket that we had for the support ticket created, where it just had this ID in it. Instead, what we have when we look at the event placed on our SQSQ is the full ticket, the full response that we got back from Zendesk. And you can see that's got things like the subject of the ticket, the description of it, all of the other details. So our consumer that's processing these tickets from that SQSQ now has all of the information that it needs to actually be able to go and react to that particular event. The last thing I wanted to just show you is that the pipe also has some helpful monitoring metrics that you can use. For example, the invocations, failures, and various other things related to the throughput of your particular pipe. So this makes it easy to figure out what's going on, what kind of throughput you're getting on that pipe, and if there's any failures. Cool. Here we go, Jamie.
Thanks, Nick. Nicely done. Always nice when a live demo actually works, for the most part. OK, so now you've heard about what pipes can offer today. You've seen them in action. But this is just the beginning for us. We're excited to keep enhancing pipes with more capabilities that enable developers to move faster while focusing on their unique business challenges. So coming in 2023, we intend to support CloudWatch logs and VPC endpoints. We'll also include support for AWS SDK service integrations. Now, this is something I'm not sure everybody has seen yet, but in step functions and in our latest scheduler launch, we have introduced a new capability called AWS SDK service integrations that allow those services and eventually pipes to target any AWS SDK API. Essentially enabling pipes easy delivery to any AWS service. We'll be able to deliver across service accounts. We will support archive and replay on the pipe. And we will integrate with SAM, CDK, and IDE, where all the tools that you're familiar with using today. So let's recap a little bit about what we learned. A pipe connects a data source. Pipes connect pull-based sources to AWS services, as well as bespoke or SaaS-based services through API destinations. while allowing for filtering of sources and enrichment before delivery. Pipes allow for over 100 integration combinations without the need to write any additional code. Pipes share the same managed polling infrastructure as Lambda event source mappings, ensuring our extensive experience in the complexity and scaling of polling, making Pipes ready to tackle your largest workloads starting today. In closing, we're so excited to add Pipes to the family of EventBridge capabilities, including event buses, schedules, schema registry, and now Pipes. Making EventBridge your first stop on your journey to modernizing and scaling your technology investments through event-driven applications to deliver better experiences for your customers and better outcomes for your business. So to get started, our blog post introducing the feature and how it works, and you can jump right into the console, of course, with either of these QR codes. So we can't wait to see some of the creative integrations that you come up with, and thank you very much.